And now we continue working with radical equations. So here we have the square root of x minus 3 equals x minus 5. So because the square root is already isolated, it's in one side of the equation, I can automatically square both sides. But now careful here, we're squaring the entire side, right? So that's why I need to put parentheses around the x minus 5. Okay, so now these can cancel out, the square root with the square, so I have just x minus 3 on the left hand side, and that's equal to x minus 5 squared. Now a very common mistake is to do this, is to say, oh, x minus 5 squared, that's just x squared minus 25. That's wrong. We need to FOIL this and distribute the x minus 5, because this in reality is x minus 5 times x minus 5. And once we distribute it, right, so x times x, x squared, x times negative 5x, negative 5 times x, negative 5x, negative 5 times negative 5 plus 25. Great. So once we simplify it, because we can combine like terms over here, we're going to get x squared minus 10x plus 25. And on the other side of the equation, still just the x minus 3. Great. Now, we have ended up with an x squared over here. And that means we should probably make one of the sides of the equation equal to 0. So what I'll do is I'll subtract the x from both sides, and I'll add a 3 to both sides of the equation. So these cancel out. X minus x is just 0. Negative 3 plus 3 is 0. So we get 0 equals x squared minus 11x, because negative 10 minus 1, there's a hidden 1 right here. It's negative 11x. And 25 plus 3 is 28. And now, what shall we do? Well, we can solve this in many ways. My personal preference would be to factor this. Okay? Well, we're looking for two numbers that multiply to 28 and add up to negative 11. I'm assuming that you guys know this. If not, check out Factoring Trinomials on our website. So two numbers that multiply to 28 and add up to negative 11 would be negative 4 and negative 7. Okay? Now, we still want to solve for x. And note that we have x minus 4 here, so that's one of the factors, right? I can make that equal to 0. If I make that equal to 0, I'm going to see that x is equal to 4. But x is also equal to 7. Think about it. If I plug in a 7 over here, 7 minus 7 is 0. 0 times anything, 0. Same works with the 4, because 4 minus 4 is 0 if I plug in the 4 for x. Okay, so now, do we have two solutions? We're going to need to check both. Let's plug them both back into the equation. First, let's try the 4. So I have 4 minus 3 equals 4 minus 5. Let's see if this works. Sorry, that's the square root. I don't think I said the square root. But let's move on. So 4 minus 3 is 1. 4 minus 5 is negative 1. So the square root of 1 is 1 equals negative 1. Incorrect. That doesn't work out. So 4 is an extraneous solution. We need to reject it. Oh, poor 4. Terrible joke. Sorry. How about the 7? Well, let's plug in the 7 and see. So we have 7 minus 3 equals 7 minus 5. So the square root of 7 minus 3, so we have the square root of 4. 7 minus 3 is 4, equals 7 minus 5, which is 2. The square root of 4 is 2. 2 equals 2, that works. So we don't have to reject the 7, and that is the only solution. So x is equal to 7. That's it. Don't forget to keep on watching our videos right here. You might have to click on radical equations. Good luck.